Okay, first circuit up here at the top is a mixed bulb circuit with one long bulb and one round bulb. First step should always be to color the wire connected to the positive end of the battery red and the negative end of the battery blue. We'll also go ahead and do our arrow tails and our starbursts first here. What we know is that once this is in its steady state, like it says right there, once that's in its steady state, our long bulb is going to be fairly bright, whereas our round bulb will not be lit. And we have some amount of charge flow that is not enough to light the round bulb, but there is charge flowing. Since it's not enough charge flow to light the round bulb, that means it must not have a very high pressure difference across it, whereas the long bulb does have a pretty high pressure difference. My color palette here does not have a good red-orange color, so I'm going to color it red on one side and orange on the other. Question 1b, does my diagram have the same or different flow rate through each bulb? Explain my reasoning carefully. It does have the same flow rate through each bulb. It has to have the same flow rate through each bulb because it's in a steady state. Steady state means that the pressure in each wire is going to stay constant. That means that the pressure here isn't going to change, and the pressure here isn't going to change. If the pressure in this middle wire is not changing, then that must mean that the same amount of charge is coming into it as is leaving it. Okay, so that means that the flow rate through this long bulb and the flow rate through the round bulb must be the same. Since those two bulbs have different resistances, that means that the pressure difference must be different in order to have this the same amount of charge flow. So the pressure difference is different. Okay, right? The first bulb, the long bulb here, has a larger pressure difference. Well, that's awkward, isn't it? If the long bulb has a larger pressure difference, then that must be more of a blue-green. My bad, guys. I've done that a few times now. Okay, the long bulb has a larger pressure difference from red to this blue-green color, whereas the round bulb is a smaller pressure difference from that blue-green color down to the blue color. Okay, so they have different electric pressure differences, but the same rate of charge flow with those mixed bulbs. Sorry about that, guys. Okay, number 2, we'll go ahead and we'll color code these again. Same kind of deal as that last circuit, but a little bit different, because we have these two in parallel. What we do know about these two different arrangements when they're in parallel is these two, since they are in parallel, they don't directly affect each other. They have the same like total pressure difference, the same total voltage across them since they're in parallel. So that means that the middle wires, they can be different colors. Since they're both mixed bulbs, the one on the left, right, the long and the round bulb on the left, with the long bulb on top, that's going to be closer to blue than it is to red. Whereas on the other side, it would be that more red-orange, because we want the smaller pressure difference to be across the round bulb. And so then something kind of interesting happens when we connect those two. We're going to have it yellow in here when we connect those two. There's kind of two ways that I've been looking at this circuit. The first way is that if we have blue-green on one side and red-orange on the other, when we connect them, it kind of allows them to average out, and right in the middle of those two colors would be yellow. So that's one way of looking at it. But another kind of different way, because wires have no resistance, we can kind of slide the bulbs around the circuit to anywhere that we want them to be, as long as we don't cross over a bulb. So we can kind of like move this long bulb, and we can move it around this wire to right here. And then we could also pull this round bulb along the wire to here, and then move that first long bulb down there. And I know that what I'm doing here is kind of weird, but that means that this arrangement is the same as if these two bulbs were switched. So if we switched those round and long bulb, it would actually be exactly the same circuit, which is sort of a more advanced explanation, but that is a way that we can look at it. The first question about that circuit, which way will the flow move the moment that we connect the wire? Since the one on the right has a higher pressure than the one here on the left, that means that our charge is going to flow from right to left, from high to low pressure. Charge is getting pushed out of here into the left wire. Which way will charge flow in the added wire when a final steady state condition is reached, to the right or left? Why? That's the question that I listed as a bonus question. What you're going to see is that it is going to flow again to the left. And I think that the easiest way to look at that here is we have charge moving through the path of least resistance. More charge has to flow through the less resistant side. And so since those round bulbs are less resistant than the long bulbs, charge is going to be more likely to move through the to the left through those round bulbs. Right here at this point where those two wires connect, less charge has to move through this long bulb, and more charge has to move through that round bulb. And so the charge kind of splits here. We've got charge moving in like this, and it splits into two different pieces at that point. And then D here, which was the other question that you guys had to answer. Describe the changes in bulb brightness that occur when the wire is added in B. So when I add that wire, right, before we added the wire, the long bulbs were both bright, the round bulbs were both pretty much off. When we connect that wire in and we see the pressure change to yellow in the middle, each of these bulbs has the same red to yellow or yellow to blue pressure difference across it. So those long bulbs, the pressure difference is getting smaller, so they'll get dimmer. And the round bulbs, the pressure difference is getting bigger, so the round bulbs will get brighter. Okay. Number 3, the key word on this question was a fresh battery. Our old batteries, as they get used up, the chemicals that are in those old batteries, they convert into chemicals that have a higher resistance. And so we see that on an old battery, the pressure does not always stay the same and the resistance increases as it gets older. But with a fresh battery, it's still pretty much a perfect battery when it's brand new. So when we add a second long bulb in parallel with another bulb connected to a fresh battery, we shouldn't see a change in the electric pressure difference across the battery terminals, and we shouldn't see a change in the electric pressure difference across the first bulb. So no change on both of those first two, A and B. C, the flow rate through the battery does change. It increases because there's another path for that charge to move through. We're decreasing the overall resistance of the circuit, and so the flow rate through the battery does increase. But since the pressure difference across that first bulb didn't change, the flow rate of charge through the first bulb does not change. Number 4, I asked this in a little bit different way on the thing, I think. I made it a multiple choice, sort of. the rate of charge in a parallel circuit will divide evenly if the parallel branches all have the same resistance. If they have the same resistance and we have two branches, half of the charge is going to go through one, half of the charge is going to go through the other. But if the branches have different resistances, say a long bulb and a round bulb, more charge is going to go through the one that has less resistance. Okay, charge will take the path of least resistance. Not necessarily all of the charge, but most of the charge. And then number 5, I asked in a different way as well. I had you fill in the blank as to whether or not, what it is that the battery supplies that's constant. It is intended to supply a constant electric pressure difference, and I kind of have realized as I graded them that really the answer to both 5A and 5B is no. It definitely doesn't supply a constant current. We have seen that. If I connect a battery to a light bulb, and then I connect it to a light bulb that has a lower resistance, the charge flow is going to be different through both. So obviously it doesn't supply a constant current, but we've also seen that as a battery gets older, the electric pressure difference across it does begin to drop as its resistance increases, though the intent of the battery is to keep a constant pressure. I believe that was the last question that I gave you. There is technically another question on this quiz that I didn't give you, but I'll just go ahead and cut it off there. I'll put this video up on Canvas. If you guys